All right, ladies and gentlemen, welcome. This is section 4.5. We are writing equations of parallel. Well, that wasn't a thing that was supposed to happen. We are writing equations of parallel and perpendicular lines today. The overall target here, we want to be able to recognize lines that are parallel and perpendicular, and be able to create the equations of lines that are parallel and perpendicular. So we've got two major things we're looking at today. Given the equation of multiple lines, I can recognize if lines are parallel, perpendicular, or neither. Or given that two lines are parallel or perpendicular, I can find the equation of a line that goes through a different point. So we're going to be using the skills from 4.1 through 4.4 to create equations of lines, right? That's what this chapter is about. So let's take a look. So first of all, some definitions. Excuse me. If parallel lines, if two non-vertical lines have the same slope, then they are parallel, right? So there's the key. Same slope, parallel. Meaning that if you have two different lines that are in slope-intercept form, right? And they both have a slope of 1/2, right? Y equals 1/2 x minus 4. These two lines are parallel because their slopes are both 1/2, right? This is an example of lines that are parallel because their lines, the slopes are both 1/2. If you want to think about it in terms of a graph, a set of lines that is parallel will go up at the same rate. They will never touch, right? Parallel lines, they're one of the saddest stories in mathematics, right? Here you have two lines that have so much in common. They're like soulmates because they increase at the same rate. They are so alike that they should be together, and yet they will never touch. They will never meet. They will never intersect. It is the saddest love story of all time, right? Two people, soulmates, running identical paths, but they will never meet. I'm going to pause for a second so you guys can all have a good cry about that sad story, and then we'll move on. Okay. Okay, I'm done doing that. Okay, so perpendicular lines, if two non-vertical lines have slopes that are negative reciprocals, then they are perpendicular. Okay, so what the heck is a negative reciprocal? Well, we know what negative things are, right? And we know what reciprocals are. That's the flip. So let's just combine those two things together. So if one line has a slope of 1/2, the negative reciprocal of 1/2, we flip it for the reciprocal and we add the negative. So the line that is perpendicular to this one would be negative 2x plus 5, right? These don't matter. It's the slopes that matter. Negative reciprocal is you add a negative and you flip it. So like if one was negative 2/5, the negative reciprocal of that would be 5/2. If something was 4, the negative reciprocal of that would be negative 1/4. If something was 8/2, the negative reciprocal of that would be negative 2/8, or negative 1/4 if we flip that. So lines with the negative reciprocals, those are perpendicular on a graph. If we have a line, so let's say we have this line here that has a slope of negative 3/2. Right? So this is my line. That's a slope of negative 3/2. A negative reciprocal of that would be 2/3. So if I started from this point that it goes through, I would go up to right 3 and notice how that line kind of creates. Perpendicular lines meet at 90-degree angles. And it's that negative reciprocal that makes that happen. So down 3, right 2 puts me there. If I were to do the negative reciprocal of that, up 2, right 3, I would get the line that meets at a 90-degree angle. So perpendiculars, they are, they're in terms of our love story, they're the opposites attract, right? They're the ones that are guaranteed to meet at that 90-degree angle, but they're complete opposites of each other. So maybe that's why we all get along so well. Okay, I got a couple questions for you in your Canvas referring to parallel and perpendicular lines. So please go to your Canvas lesson and answer those 2 questions.